we saw different standards actually, and we recognized the basic and the very commercial and let's say publicly used uh, standards for the encryption. And the same that use for the decryption, we saw some features related to their work, how they are utilizing the keys and the notion of the keys, the public and the private keys. We saw last class when we defined the use of the hashing scenarios to secure a communicated message or the purpose of the message authentication. Uh, yes, and we discussed the requirements of the hash process. And this was the last, actually, I believe, that we discussed so far. Yeah, and yes, from here, actually, we keep going on. The hashing actually is a scenario via which the cryptography is seen in action. We can see a standard, which is an algorithm dedicated to hashing, to play the role of the hash function, to hash a value, a media, to generate a hash value. The hash value is, as per the definition we saw, it is uh, with the same length for all the medias hashed with the same function, with the same hashing function. And it is actually a sort of a cipher that we cannot understand, or we as humans, we cannot have any meaning. It's meaningless for us. But it is something with a value to the computer, to the, let's say, to the security context. Yet, it is not the least of the security approaches that we can go for, since it has some drawbacks and it is vulnerable to different attack techniques. It can be broken, this security approach. We defined at the first, at the early age of this unit, the first class of this cryptography unit, the context of the crypto analysis and brute force attacks. Still, this hashing function can be actually broken using those techniques. Remember, we defined the hash technique, the hash yes technique, as a one-direction process, means it cannot be reverted. Yet it can be broken using the brute force attack or the cryptanalysis attack. How? It does not mean that we are going to break the hash value to get the original media. No, it is not like that. But we are going to hash new medias to match with the hashed value that we try to break. Thus, it can be broken. So that can be actually a comparison using a dictionary already stored, or we are going to generate a new lexic hash and values, and we compare them with the origin, with the yes hash value in question. Yes, any questions, please?
دكتور
Yes, Aya.
في بنات يريدن يدخل المحاضرة.
Let them ask permission. I did not see. I do not have any notes here. Let them send the request or just try to access again. خليهم يدخلوا مرة ثانية. This same scenario actually we use here. One step further. We talked about the symmetric encryption and we talked about the conventional encryption, which is actually a scenario via which we see a public key utilized by a sender and a receiver to encrypt and decrypt a media, to encrypt the media to generate a cipher, and then after to decrypt a cipher to generate the original media using the same public key or the same conventional met conventional key. This is not the ultimate scenario in cryptography. This is not the ultimate scenario in cryptography. The cryptography actually is a little bit more complex when we see the public private key in action, when we talk about the asymmetric, the non-symmetric cryptography mechanism, where we can see public keys utilized by a sender in plural, and a private key matching each public key, a private key matching each public key utilized by the receiver. to decrypt. The public key would be utilized by the sender to encrypt. The private key would be utilized by the receiver to decrypt. Public key used by the sender to encrypt to generate cipher. Private key utilized by the receiver to decrypt to generate original media starting from cipher. This is how the story goes, how technically it happens. A sender, let's say we're using a social media application that uses the cryptography as a security approach, and this cryptography, it uses the scenario of the asymmetric, non-symmetric cryptography, encryption, decryption scenario. Thus, for each session, for each user that uses that social media from that device, from this device, the device or the application in question would utilize a public key for that user. Saying in this graph here, Alice here, see the Alice here, in this graph, Alice is using, let's say, this media, this application, this system, to send or to share this media, this text. The public key for Alice, the respective public key for Alice is played in action. Here it is, to encrypt the media, which is the X, to generate the cipher. Once this cipher generated using the public key of the respective user, it will be transmitted, then received by the receiver. The receiver, what he would do, the application in question, the server side, would check and recognizes that this media is from Alice, thus the public key is from Alice. He would search and utilize the private key of Alice, stored locally here in this device, to do what? To decrypt this received cipher, to generate the original media, decryption of the cipher, the Y, using the private key, respectively linked to the public key, to generate the original media. Any questions, please? Any questions, please? This is actually a scenario via which we talk about confidentiality, the C and the CIA triad and security, via which we are talking about confidentiality. We generate the encryption, we are encrypting, so we are sending confidential data, a classified data, which is a cipher. When we look from the other side, how this receiver, this server, recognizes the private key, the respective private key related to the sent or the received public key, we talk about authentication. Means the scenario, the receiver here is going to make a decryption of a media received through a channel, communication channel, but this media is going to be decrypted unless the communicated media has been recognized. When recognized means there is a key. Here it is said to be public. This is a server, this is the client, this is the browser you use in your device. Once the media communicated here is recognized, so this media here is sent to you. This device will decrypt the received media using the public key, locally, whatever, it's public key, but after being authenticated. So the authentication is in question here. Conclusion. When talking about the confidentiality, the public key is with the sender. When you talk about authentication, the public key is with the receiver. Because, saying the example of the University of Lisbon web site, it is secured. Or the favabay.com, the portal we use in lab, it is also secured. Okay, when we request the page to open, we are the sender. We are using the public key. We are communicating securely. So this is the confidentiality. When the server replies to us and sends us the page content, and he will open us the web page. So we are the receivers. We will receive the page, and it will open in our computer. So we are the receivers. So this is an authentication process. Any questions, please, here? Concentrate and tell me if you have any questions, please.
Mr. Again, please explain again.
Yeah. We have two scenarios actually via which two parties they are communicating, saying that we are visiting, for example, University of Lisbon website, the portal of the University of Lisbon. This portal here, we are going to visit, for example, the main interface to see what are the news, what are the newly updated news that the University of Lisbon website is shown to everybody. So we open the client, which is for example, the Google Chrome, and we type the URL www.uniswo.com. The uniswo.com is secured, so it will change to https www.uniswo.com, whatever. This process here, there is an encryption scenario, decryption scenario in question, encryption, decryption scenario in question is running. So there is a cryptography since it is secured. Okay, good. We are either a sender or a receiver. Who we? Actually, me, you, everybody is using this website. We are requesting or we are receiving response. But since we are asking for the website to open, so we are the requester, the ones to send. Okay, to do so, our device, our client, the Chrome, the Google Chrome, has to use a public key to secure our request. The request is the plain text, www.uniswo.com. It will change our request into cipher. How? Using a public key respective for us. In this example, for example, the user name is Alice. Ali, Absattar, Murad, anybody. The computer will know this is for this user. Okay, public key he will use to encrypt the request and send it in format of cipher. This is a confidentiality because he is securing our request. This is confidential, classified, secured. The receiver, which is the server, he will decrypt using what? Using a matched private key to the same user. How will he recognize? It is in the authentication. He will decrypt using a private key that matches the sender's public key to decrypt and get the request. How he will match? This is in the authentication process. The authentication process, there will be a matching actually. Actually, this is from the other side. The sender, which is the server now, he has recognized that the respective user has requests tell and tell. He will produce that, but using a private key, he will encrypt and send the ciphertext, which is the encryption of the media using a private key. The receiver, which is me, you, which is any user, he will receive the ciphertext and he will decrypt. Decrypt using what? Using a public key, because he has only a public key. He does not have a private key. He's a user. He has a public key. So in the authentication, response means he will decrypt using a public key. But when requesting, the decryption using a private key. That's it. Very simple. So we keep going on. We keep going on. So the key requirements, actually, it has to be confidential enough. This is for sure. This is common sense. It is a matter of in the scenario of the asymmetric, the non-symmetric encryption or cryptography. There are pairs. Pairs. What does it mean? The private and the public, they have to be correlated. It's not any private with any public. No. Bob's private with Bob's public. Alice's public with Alice's private. So there is a pair to work with. Public with private, private with public. Murad public with Murad private, and so on. Khadija public with Khadija private keys. There are pairs. Pairs means it's not any with any. No, it is not. Then, in a matter of computation, it has not to consume time to compute to get actually the matching in between the public and the private. It means the receiver will not find a difficulty to find which private is for the public and which public is for the private. There has to be a scenario via which computationally it would be actually easy to find. In all cases, they have to be actually useful for their roles, in the sense of when we use a private key for the authentication, the private key has to play the role perfectly. And when you use a public key for the confidentiality, the public key has to play the role perfectly also. So they have to be useful, otherwise they are useless. Standards for such scenario, usually now we are talking about the asymmetric. So those are new standards, those are new algorithms than the ones we saw last classes. The RSA, these is actually one of the very famous scenarios, the very famous algorithms, sorry, and it is named RSA. Why? Because of the name of the developers. They are names of persons since the year 1977, whatever. The standards we use here, they are also very famous, and they are actually to be utilized for the asymmetric cryptography scenarios, asymmetric, non-symmetric cryptography scenarios. Any questions, please, before we pass to the next topic?
No, Mr. Thank you.
Okay. I'm gonna just finish by this topic, which is the public key certificates. Okay, that's great. So still like with the conventional or the symmetric encryption, we are not going to make an asymmetric or non-symmetric scenario for the purpose of the asymmetric or the non-symmetric purpose. No, but we have a service to do. We have a functionality to do in order to, for which we are going to deploy or to use the asymmetric or the non-symmetric scenario. Great. From the usabilities of the cryptography here in this view, we talk about the certificates and the digital signatures, where we see actually a generation of a certificate to be shared between a sender and the receiver for the purpose of authenticating the communicated media. A certificate is a proof of ownership, and this is a legitimacy to say that this content is secured. It is guaranteed. Certificate is a sort of digital. It's a sort of a digital value to be shared between the user and the sender, no more or less. Media. It holds the data of the sender, the ID, the public key utilized, and if there is any other data that can identify, the sender. The sender, remember, the certificate, the media owner. This certificate here is going to be hashed using a hashing function, and this hash value, the generated hash value, would be encrypted using the asymmetric scenario, and the encrypted value would be concatenated to the original certificate, and this concatenation here would be shared with all communications to certify that the sender is certified. The receiver will do the vice versa, the reverted. He will use the media, the certificate, to generate the hash, and again, he will encrypt the hash using the same standard. He will compare. The encrypted media, is it the same? If it is the same, yes, so the certificate is valid. Otherwise, the certificate is broken. So, any questions, please, at this level?
No, Mr.